Good morning, ladies and gentlemen. Hope everything's going well. So we're going to be starting our new unit today, and that is on weathering and erosion. So weathering and erosion, two related topics. Weathering is whenever anything gets broken down. That's like rocks being broken down, or if you were to go to a cemetery and see the gravestones, they start to wear over time, they break down, they become more smooth. That would be weathering. Even down to the point of a chain link fence. So if you saw a steel chain fence, you would see rust on it. That would also be weathering. Erosion's a little bit different. Erosion involves the carrying away of sediments. So when you go to the beach and you build, let's say, a sandcastle, over time the wind and the waves are going to carry everything away. So today you would have got a handout, mini lesson, talk about rates of weathering for a while, and then my plan was to have a physical weathering lab to be done. I'm not sure if the sub is going to do it for you, or for those of you that have Miss Garraway, you might be doing that. So there's that. We do have a Castle Learning homework tonight that will be due on November 23rd, 2016. So basically, if you can get that done by Wednesday night, by midnight, that should be good. Also, you should have turned in your performance tasks. Those need to come in. Ms. Garraway will be collecting them and holding them aside so I can grade them when I get back on the 5th of December. Okay, so a couple of things. If you take a look at this image here, you see a perfect cube. That original first cube, which is right here, you can see that it has 6 sides. If you were to dice it up and break it up into these 8 cubes, you can see that there's more corners, more areas. If you were to cut them up again into 64 cubes, you can see that there would be even more areas. Alright, so this is the whole idea of surface areas. If you take a look here, the bottom illustration, you got attack on 2 sides. It's basically wind, water, rain, the environment, a cat walking over to it and knocking it over. Those things are all going to break down cubic shapes into more of a round shape, especially for corners. Right, these 90-degree angle corners here, you're going to get attack on 3 sides. So basically, a full solid block has the least surface area. The interior is safe from exposure. A smashed piece has the greatest surface area. The interior can now be attacked. Think of it this way: if you had a glass of hot milk and you stuck a chocolate bar in it, sure, the chocolate bar would melt. But if you broke up that chocolate bar into a bunch of small little pieces, almost like dust, and then dropped it in there, it would dissolve almost instantly. I believe this was supposed to be the do now. Let's take a quick look. I'm not sure if you guys are going to get this because we had to skip over rocks and minerals, but I'll give you a minute to take a look at it. Basically, it says diagram below shows a rock formed with intergrown crystals. It's deformed. This one would actually be heat and pressure. So the answer would be 2. Heat and pressure changed a pre-existing rock. This rock we actually call schist. It's a schistostic rock. For number 2, which process is necessary for the formation of igneous rocks? Igneous rocks are created by lava solidifying, so that would be solidification. And then lastly, number 3, which type of rock most likely would contain fossils? And this one, really, there's only one type of rock that contains fossils, and that's sedimentary rocks, and that would be shale. Bonus points if you got that, because we really didn't talk much about these topics yet. So, surface area exposed. Weathering occurs on the surfaces. The more surfaces exposed, the faster the rate of weathering will occur. Now, mineral composition is a big thing involved with this. If you had a house made out of diamond, extremely hard, it wouldn't weather over time. It would stay the way it is. If you made your house out of very loose packed sand, which can break down easily, the first windstorm, your house is gone. Quartz, for example, is a very resistant mineral. It takes a lot to break it down. In fact, many acids can't break quartz down. Now, if we take a look here, we have 2 illustrations. The one on your left right here is a gravestone that is made out of limestone. And here we have one that's made out of granite. Take a wild guess as to which one's older. You're wrong. It's actually this one. This one's from the 1700s, whereas this one's from 1893, I believe that is. So depending on what it's made of, that really shows you how long it's going to last. And I said it was marble. I said it was limestone. Limestone turns into marble. It's essentially the same material. So, question is, where is the rock more resistant to weathering? A, B, C, D, E, or F? The most resistant. My guess would be F. Hello! Ooh. Now, what about hello, the one that's least resistant? In that case, yes, it would be D. Now, you might also see it a different way. You might actually see it vertically.
Don't!
I don't know why my animation's not working. Climate conditions. So climate plays a big role on it. The hotter the climate, right? Usually the more chemical breakdown you're going to have. But really, just to go back to what we were talking about a few weeks ago, climate, the average temperature and precipitation. Cold, wet areas favor physical weathering. Physical, again, means like things smacking into each other to break them down. Warm and wet climates favor chemical weathering. That chemical weathering, again, would be something like acid rain. So a couple quick readings questions. Number one, landscapes will undergo the most chemical weathering if the climate is what? Cool and dry, cool and wet, warm and dry, warm and wet. Landscapes will undergo the most chemical weathering if the climate is warm and wet. 2. As a particle of sediment in the soil breaks down into several smaller pieces, the rate of weathering will do what? So if you break rock down into smaller pieces, will it weather faster or slower? Right, it's going to break down faster, so that would be an increase. So is it an increase due to a decrease in surface area, or an increase due to an increase in surface area? Right again, increase due to an increase in surface area. Which statement best explains why the dates are more difficult to read on Tombstone A than Tombstone B? Tombstone A is from 1922, Tombstone B is from 1892. It's harder to read Tombstone A. And the answer for this one lies in what it's made up of. So Tombstone A, it's light colored, and it seems to have worn away quick. My guess is it's probably made out of marble or limestone, whereas the darker one's probably made out of granite, something that's more resistant to weathering, especially chemical weathering. So, which statement best explains why the dates are more difficult to read on A than B? A has undergone a longer period of weathering than Tombstone B. No, that's not true, so it can't be B. Tombstone A is composed of materials less resistant to weathering than B, so the answer would be A. Right. I don't know why I looked at B first. There you go. Alright, so I'm going to continue trying to keep in touch with you guys. As far as today's lab, if you're with Miss Garraway, you're probably completing a physical weathering of sugar cubes lab. That one, get it in as soon as she tells you to, which I think she's going to make it due on Wednesday. Other than that, if you guys don't have a sub, again, I apologize that you're doing this without me, but please keep reviewing the videos that I'm putting up, and please make sure that you get a CAS alerting in, because I have to have some kind of assessment for you. So CAS alerting assignment, it is due on November 23rd, 2016. It is up and active until 11:23 at midnight. And that is it. Have a wonderful day, guys.